All right. So today we carry on from where we left off. Ike, stay with me, okay? All right. So the principles of GIS. Revolve around the components, isn't it? Did you talk about the components of GIS? Did you talk about the components of GIS? We didn't? All right. But we described generally what we're, or everything that we're going to talk about. Then we started touching on the applications, right? So we said it can be used in urban planning, local government, can be used in health. It's like anything you can think about, it can be used there. Fishing, navigation, piloting. Are you okay? So the students should understand that you are really facing a very high hurdle that you have to jump over when you do a course like this. Literally everything around you can come in the exam. The only thing I'll do is that I'll describe it to you. Is that okay? Yes. I'll describe to you how water is distributed. Then I'll now ask a question about it. Then you're now supposed to see it from a GIS point of view. Is that okay? All right. So that's why I said that GIS is like an elephant. Again, why? Because you just don't know exactly what it is. And that's the reason why you can fail it. You can fail the course. Because then it's like as if you know it, but your answers are wrong. So pay attention and understand what I'm describing to you. Are you okay? Because if those blind people had someone to tell you what you are looking at is an elephant, are you okay? It is so huge and heavy. Are you okay? And it has this, they wouldn't have had a problem, would they? All right, but when they start looking at it in parts, then it's like, we don't even know what we are looking at. Are you okay? So please don't underrate it. That's all I'm saying, because people have failed it. I have to tell you. Okay, if you missed a lecture, we've said a lot about geography. Okay, so we're not going to talk about it again. What's geography? I see new faces. Or you were all online, were you? Someone shaking their head. All right. What is GIS? Definition, write one definition down. Anywhere you want to write it. Ruben, are you there? Can you hear me clearly? Hell is also there. Okay, that's good. Write down the definition of GIS if you can. There are three types of definitions. The first one is a two-box definition. I think last week we started with that, isn't it? All right. So two-box definition of GIS. Write it down. A powerful set of tools for collecting, storing, retrieving at will, transforming and displaying spatial data from the real world. Powerful set of tools for collecting, storing, retrieving at will, transforming, and displaying spatial data from the real world. Okay. All right, so you don't have to write, but I think writing is part of it. So once in a while, I tell students write, but they don't get the idea. I'm not forcing you to write. I'm just giving you an idea. Is that okay? That if you like taking notes, you are preparing for exam. Are we good? All right, great. So a powerful set of tools for collecting, storing, retrieving at will. So that they are commas. Are you okay? Right. Collecting is comma, storing comma, retrieving at will comma, transforming and displaying spatial data from the real world. Are you okay? The understanding of this definition is very critical for you passing this course. If you don't understand this definition, that's one of the reasons why you're giving the wrong answers. Is okay? All right. So here, the definition mentions or touches on the real world. What is that real world is talking about? What's the real world? Why is he talking about the real world? We've already talked about some of these things, but let's touch on it again. Why are we talking about the real world? Does it mean there's another world? So those who didn't take part in the previous lecture, we totally lost. I talked a lot. Are you okay? So why do we say the real world?
I think it's One, the surroundings we can relate to at everything also. Like anything we are looking for, we see or
physically, what we see around us, that's the real world. And we're saying that because we want to represent the things around us, our geography. In GIS, that's what we are doing. This statement is the most important statement I made throughout the whole lecture. Is that okay? 8 weeks that we are meeting. Is that okay? And do you understand it? Make sure you understand it. Is that okay? We are representing geography. Are you okay? How are we representing geography? We are modeling our world. Are you okay? We are modeling. So a model of a car can look like something that you can literally hold. Are you okay? That's the model before they build it. Are you with me? So the real world is really big. It's a large expanse. Are you okay? Of space that we can find all sort of objects, people, and phenomena. Did you hear what I said? Objects, people, and phenomena. Are you okay? All right. So if you have a set of tools that allow you to collect and store spatial data, store data, spatial data, that means a special type of data. So if you are very good at computers, you will know data, but this one is spatial data. Is okay? That means that we can associate location with that data. Are you okay? All right. So I should be able to extract and get to know the Indians are here. Once I can do that, that's GIS right there. Once the Uber driver can come to your house and you're going like, are you kidding me? I'm just coming from 1922. How did you do that? To get a taxi to come and stand in front of you. How did you do that? Right there, that's GIS. A query was made. The Uber drivers call it a request. You probably call it a request because you make it, don't you? All right. So that is what we are calling here retrieving at will. I'm lecturing here. Are you okay? Don't think about lecture notes. Understand what I'm talking about. Are we on the same page? All right. Someone is making a comment. Well, am I not? He says, please, sir, please. Okay. All right. That was said at 2:30. What time? Okay, 2:45. All right. So they can hear me. Fine. Do you have any questions? We can look at GIS as if it's a database. Have you all done introduction to computers? You do those things. Are you taught what databases are? What it is? I think you should be taught, isn't it? Because when we go online, all the things we're doing on there is querying databases. Are you aware? All right. But databases are very simple. They are a set of organized, when data is organized into one container, or when you have organized data, you have the database. Are you okay? Also, you only have databases because you want to query them. Are you okay? All right, so you can look at GIS as if it's a database. You can look at GIS as if it's a toolbox. That's a toolbox definition. We just looked at that. We can look at the database definition of GIS. Is that okay? All right, here it is. Database system in which most of the data are spatially indexed. So now you don't have to write. Right? If you are quick enough to write, fine. But you don't need to. I've sent this to your page. Look at it. And upon which a set of procedures are operated in order to answer queries about spatial entities in the database. Is that okay? So when you query any database, you get a certain result. Now, when you query this particular database, you get spatial entities. Okay? Most of the data are spatially indexed. The data in this particular database is spatially what? Indexed. What it means is that every database person knows that the index is important. In fact, that's the reason why you are giving student index numbers. Okay? Every database person knows that the index is what allows you to search quickly. So in this case, the data we have are spatially indexed. Okay, that's English language. Are you okay? What does it mean? It means we can uniquely identify every single data. Okay? All right. Any question on the definitions? I hope you're good. Any questions? Augustine, Ruben, Pearl, all of you out there, do you understand what I'm saying? Look at them tell me that you got a B, you expected an A, and I give you a What am I even saying? I'm just saying that please try and understand what I'm saying. Is that okay? Can also do group discussion. Yes.
I just wanted to ask whether
When you're asking the question, always take off the mask and then you put it back on.
okay. I wanted to ask what GIS stands.
Wait, that's because you missed the first lecture, isn't it? And did you ask a permission? Then in that case, I could do that. For being absent? No.
I was present, but I
Came late. And did you apologize for being late?
Because
so you should first say, I'm sorry. That's the only way
I'm sorry,
you can get me telling you what it is.
I had the old timetable. The old timetable is said that it was
in the morning.
Yeah, in the morning. So
okay. All right. So Ike is going to tell you. Just tell him, okay, for me. Are you happy? All right, Ricky. So there's a lot that we said, but you take that from now. Is that okay? But literally, it was about what we're going to talk about. It wasn't really about the details. Okay. Are we all happy with so far what has been said? Okay, I'm asking on purpose. At a point, don't say you're lost. I'm telling a story. Is that okay? All right. So the components of GIS. The first one is hardware. The second one is software. The third one is, there are 5 of them. The third one is data. The fourth one is people. And the fifth one is methods. So what is hardware? What's your name? Jomel. Luamel. I think my mouth has to go right. Okay. No. What's hardware? What's hardware? In computers, what's hardware? Physical components that we can touch. Are you okay? Now, because GIS makes use of computers, then when we talk about hardware, the computer is part of the GIS hardware. Are we on the same page? So you should know about how the parts of a computer, same way you should know it in IT, you should know it in GIS. Are you okay? So one component of GIS is the computer itself, the hardware. Are you okay? So every part of the computer, you should know about it. If you are going to call yourself a GIS expert, are you okay? Someone can use GIS. So we need to understand the role of the screen. What does the screen do? For this, to display information, to visualize. Are you okay? Visualization happens on the screen. Are we on the same page? All right. What about other hardware that you can mention? Keyboard for input, isn't it? Okay. What else? A systems unit. What is in there in the systems unit? The processor. Okay. So what's the role of the processor? For processing the data, isn't it? All right, okay. How do you measure how good the processor is? What's the RAM? What's the RAM? The RAM stands for random access memory, right? Okay, so when you're running any software, you are making use of the RAM, the memory. Is that okay? Then and we differentiate between the memory and the storage. Are we good? All right. So you see, GIS is interesting. I'm still talking about GIS. I'm just going into one end. Are you okay? I'll come back home. Are you okay? Please don't lose track. Okay, don't lose track. So the bigger thing, it's made up. It's like something like that. Are you okay? So I've just gone into one end where it's like I'm an IT person now. Okay. When you are a GIS person, people confuse you. They think you're an IT person, but you are not. Are you okay? And you are not a mathematician, but you are not a scientist, but you are. Are you with me? All right, so I understand this. Is okay. Software has to, what's a good software? What does software do? Instructions, are you okay? That are being executed by a machine. Are you okay? All right. Good software has to have functionality. The functionality should map to the business rule. Are you okay? So if you want to drill in, your software should be able to tell you that drill this deep. Don't drill this. Are you with me? Because it's now linking to your business. Are you okay? Drill at this angle. Are you all right? So there's good and bad software. Every good software should be able to update. It should be updatable. It should have documentation. It should be robust. That means that it should be able to envisage that this person is likely to click this button. All right. So software that's complicated, don't say, that software is hard. Don't be excited. It means they didn't do it well. Is that okay? You should do, if you can't use it, there's something called human-computer interaction. If you can't use the software very well, it means the software designer didn't do a good job. Okay. It should be so easy to use, almost always. Okay. So software contains the programs that run. Okay. All right. How do you measure the processor? How the processor works? How good the processor is? What's the unit for measuring how good your processor is? Hertz. Hertz. Is that okay? Hertz. Frequency. Speed. Yeah. Frequency is speed. You are aware. How frequent you go to? Are you okay? You do something. It's speed. Are you all right? Okay, so 2 gigahertz, get it? How many zeros? So 2000 megahertz is 2 gigahertz, right? 2 million kilohertz, still 2 gigahertz. So now I'm going to billions now. Are you okay? It's far above million. It's all right. Please appreciate that. But just know. All right. How do I measure how big my RAM is, my memory is in bytes? Are you okay? Bytes. Now every byte is made up of what? 8 bits. Everybody is made up of 8 bits. Okay. So information, everything you put into a computer, the basic unit is the bits, which actually represents an on and off state. Is all right. So when you take a picture right now and you send it to your laptop, and you look at it, I'm so cool. Are you okay? I can just take a picture. It's on my laptop. Are you all right? When you do every single square in that picture has to be stored. Are you okay? As a byte or something like that. Are you okay? You can break it down and store it as a value, single value. Are you okay? And it has to be converted. Whatever the value is, has to be converted into binary. So if you write hello, the H there is binary. Are you okay? The E is binary. The L is binary. It's the whole. Are you okay? And it's like as if you are switching on lights and switching them off. And we know that that's code. Are you okay? That's code. All right. Let's understand some of these things. What else should I talk about? Software. I mean, you know what software is? Hardware. What again? Data. Let's talk more about hardware. Is that okay? So in GIS, we can have 2 hardware accessories. You know, you can have what we call accessories to a computer, right? Things you can connect to the computer itself. You can have what we call a digitizer. Then you can have a scanner attached to the computer. Is that okay? So the scanner simply turns whatever you put in there. You know, scanners, how they work, right? Turns it into a picture form. In fact, you don't want to say a picture, I want to say an image. So you scan a hard copy, then you obtain a soft version, which is a picture of it. Are you okay? All right. What again? The digitizer. How does the digitizer work? Digitizer, literally, are you okay? You can get points from it, points, coordinates in some kind of local coordinate system. What you do is that you place the hard copy onto a board, digitizing board, and then you connect it, the board. So the board has its own coordinate system. Then you take a digitizing pack, then you start clicking on any object you see on the hard copy. Okay, so let's see, you see a shape like a square. You click along the shape of the square, then it will go into the computer as 4 points representing the square. You get the idea? That's how it, so the digitizer doesn't give you an image. It rather gives you what? Coordinates. Okay. So if you see a river and you want to digitize it, you click along the shape of the river. Then you are digitizing it. So it looks more like the scanner gives you a picture, but this one gives you a sketch. Okay. But that sketch is a digital form. It's in coordinates. Are you okay? Are you on the same page? All right. What are some of the cautions or precautions that you should take? Oh, wait, please. Check. I know, right? Are we talking? So the digitizer, what are some of the precautions? One is a digitizer. Digitize as much as you can. Okay? So you don't digitize a bit, go and play football, come back, yeah? Go to some artificial football park, go and just play, come back, let me just continue digitizing. You don't do that, it's okay. Digitize as much as you can. So lunchtime, you go for lunch sometimes. So you don't, okay, let this guy digitize. I want him to also run some errands for us. You don't do that, it's okay. Right, there's a reason for the accuracy. Accuracy is always a reason. Okay. Also, you should consider the coordinate system when you digitize. It's okay. You should also look at the accuracy of other data sets that you are going to integrate whatever you are digitizing with. Is that okay? All right. It's very important that you don't have two different people digitizing. Like you come and digitize, okay, you come and continue. Because your idea of where the forest ends is different from my idea of where the forest ends. Are you okay? So maybe I'm choosing certain, areas that look like, sparsely distributed. Are you okay in terms of vegetation? And I think, okay, that is what forest is. For you, it's not. So now, when we finish digitizing, some parts look like forest, some parts don't, and yeah, it's not accurate. Are you okay? But bottom line is that you should take these precautions when you digitize. Is that all right? You can do point mode digitizing, and you can do on stream mode digitizing. So in that case, and you can do on-screen digitizing, 3 types. Are you okay? So point mode means that just pick your point. Okay, I want this point mode. Are you okay? Select the point. The operator, whoever is doing the digitization, picks the points that he deems what forms a part of the geomorphology or the shape of the feature. So the word feature means an object. Is that okay? Your mail, you understand? Did I pronounce it well? It's close, eh? Okay, so that's point mode. You can go into stream mode. That in that way is we have that in an automated kind of mode. Are you okay? So the system now collects the point. It's like it goes into a mode in which every second or 2 seconds picks a coordinate. So all you need to do is you don't have to click, select the point. It's already storing coordinates. Are you with me? So when do you think you use it? For which feature? A small, a very large, long feature, or a compact and small feature? If you set the system to be, okay, start collecting coordinates. The idea is that you'll be moving it, isn't it? Then it will be just collecting the coordinates. You don't have to be click, 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 click. Get it? So what kind of feature would you use this mode on? On some long feature, are you okay? If you are doing, say, the shoreline, are you okay? Doing all the way from here to Togo or something, and you have a way of just moving it. So just be slowly doing that. Now you'll be singing a song, are you okay? But just be careful, are you all right, that you don't make mistakes. All right. The on-screen digitizing, we'll do it, we'll probably do it as a tutorial, is that okay, in class? So you do it on your computer. You don't need the digitizing board. Are you okay? The digitizing board looks like a board like this. Then you just mount your hard copy map. Normally it's a map. Are you okay? Don't forget that a representation of the real world is a map. Even though I'm not seeing a map, this is that. All right. But I'm intentionally not seeing a map. But when you actually bring that representation, when you print it out, when you generate a hard copy of the representation of the world. When you print it, it becomes a map. Are you okay? But I wasn't calling it a map earlier because I'm not saying I'm going to print it. It exists on my computer. Are you okay? Right. So that is it with digitizing. Basically, that's it. And digitizing is linked with the digitizer, which is actually a hardware component. Do you see where we are? Yeah? All right. So where do you think we are? That's a question to the class. Where are we? What? I'm still back in components, isn't it? And I'm on data now. Are you okay? All right. So what's data and how is it different from information? Data is raw. Okay. Data is raw and unprocessed. Are you okay? When we process data, then we get information. Right, but the thing about data is that data can be collected in-house. You can just collect data. Are you okay? Or you can compile it. You can just someone can compile it and just go and take it. You can compile it yourself, collect your own data, or you can just buy it. Are you okay? All right. Whether you buy it or you collect it yourself, you should know that data can be measured on a scale. Is that okay? All right. So there are about 4 scales that we can measure data on. We can measure data on what we call the interval scale, the ratio scale, the nominal scale, and the ordinal scale. Anybody collecting data in Ghana, who is authorized to collect data in Ghana? That's the word, statistics. Is that okay? So ordinal data, interval data, nominal, this is statistics. In fact, it's just coming into what we are talking about. Because we are talking about data. And data is always going to be what? Data. So for statistical board, they see data, they will know this is data. They don't care whether you are civil engineer, collect data. They can look at it and say, this data is key. This data is like that. Are you with me? All right. So what we're saying is that data can be put on a scale. It's not like you are going to measure how big it is, but it's like you get to know that there are different types of data. Actually, be careful saying data type. It's different. It's a different thing altogether in computers when you say data type. Is that okay? I'm talking about attribute data. What is attribute data? Attribute data is the data about object or a feature. Are you okay? That is what we're talking about. Okay? All right. So nominal data, if someone collects nominal data, he's collecting data about names of objects and things like that, like street names. An example is street names. Nominal data, example is what? Street names. Okay? Because nom is French. If there's a French person here, they know that nom means name. Are you okay? So that nominal is name we are saying. If it was said truly in English, we would have understood it. Are you with me? But now we are wondering what is that coming from? Are you okay? All right. Ordinal data means data that can be put into what classes. It can be grouped. Are you okay? Example is road classes, soil classes. Okay. All data you collect can be put into these 4 categories. Are you okay? Then we come to the last 2, interval data and then ratio data. Is that okay? So interval data is data in which the interval makes sense. Okay. So example will be what? Temperature. Okay. Do you prefer to be in a room which is 70 degrees Celsius or you prefer to be in a room which is 35 degrees Celsius? Ike, do you prefer to be in a room 70 degrees Celsius or a room which is 35 degrees Celsius?
17.
You want to be in the 17?
Yes.
Why?
I prefer children.
Bad answer. This answer is an answer coming from social science, not from an engineer. Is that okay? No, I'm not making. I just want the class to understand the concept. Is that okay? All right. So why would you want to be in a 70 degrees Celsius room and not in a 35 degrees Celsius room? We all know that normal room temperature is what? What is it? Huh? Should be, yeah, exactly. It shouldn't be too hot. I mean, like, but anyway, that's used in calculations when you do physics and all that. Is okay? But that's really not the reason why. Because 35 is greater than 17. That's the reason why you want to be in this 17. But anyway, when it gets too cold, you don't want to be in it, isn't it? Right? Okay. But so what are the numbers measuring? They are measuring what? Hotness, isn't it? Or coldness. Are you okay? And the more you have of it, you go on a scale of being too hot or being too cold. Is that not so? All right. So I like the way this is going. Now, when it's getting, the numbers are reducing. We thought it should be better when it was 35, isn't it? Now it gets to a point where you're like, yeah, are you okay? I said I want a cool room, but it's okay. Are you all right? Please, you just put it off. Have you been in a room in which everyone feels like, oh, we are okay, and you are feeling like, hey, I'm really sure. Are you all right? The point I'm making is this: that there's no absolute zero when it comes to temperature values. There's no absolute zero, which means that zero is a value. But zero was supposed to be nothing, isn't it? So interval data should be distinguished from ratio data. For ratio data, zero means there's nothing. Okay, let me give you an example. Example is weight. So all of us, I bring a scale here, and then those online, everyone, we come and stand on it. Are you okay? And then we measure what? Weight. Is that also? And we are recording it. It's data. Is that also? All right, great. So stand on it. What's your name?
Richard.
Richard. So Richard stand on it. It's okay. I'll say Richard, even though you say Richard. All right. So Richard stand on it. My friend is called Richard. It's like we always call him Richard. It's all right. And then Richard stand on it, and then Richard is weighing zero. Are you okay? And everybody goes like, what are you gonna say? Like, get a scenario. He stands on the scale, it reaches zero. What are you gonna say? Oh no! Then you have to jump into conclusion. Yeah. No, it's because you understand what I'm talking about. So you straight away you're going there. All right. It means Ike understands it. Are you okay? All right. Backbenchers. So Richard weighs zero. What does it mean? What would you say? You say he's light. Nonsense. It doesn't make sense. I'll be honest with you. What you say doesn't make sense. You bring a scale now, he comes and stand on it. You will say he's light. Online people, it will end in 5 minutes. Reconnect. What would you say? Now your name of just general. I use quite the name for you. What would you say? The first thing that we will say is that the scale is not working. Sir, say he's light. Say there's something, Charlie, there is still not the work, isn't it? Now, Pidgin is an official language, so I can speak Pidgin even for this lecture. Is that okay? Charlie, the skill not the work. Make you go downstairs, make you bring new what? Skill, make Richard stand on it, you bring it again. And then someone go like, let me also try it. So if he also tries it and he waits, the thing moves. Our concern will now be on Richard, isn't it? Richard, the Richard will go like, okay, let me try it again. But it's not normal for your weight to be zero when we can see. You can say matter is anything that has prices. Are you with me? So that weight data is ratio because the zero means there's nothing there. So if Richard stands on it 10 times, zero, everyone stands on it, it reads. The next thing is that two people should just what? Run away because he's not normal. He's just some alien or something. I'm using as an example. Is that okay? You are not only a fine word. All right. So we just spoken about this is the attribute data. Are you okay? Attribute data scale. Are you okay? So all right. So that is it. All right. What else should we talk about? We just talk about data, people. Yeah. People. I watched a movie and the pastor said people before he said whatever he said. He said people with that pitch. Is that okay? Why would he say that? People are a problem. People. Africa. People. I was a problem. Every system is a people that destroy it. In fact, you design a nice software. Are you okay? People will just bring it now. They make you look useless. Okay. Do you know that WhatsApp, the version we are using, it wasn't the first version. That's not how you like. When they show you the first version, you wonder, I should have started WhatsApp myself. I'm the rich man right now. Are you with me? What have we done to WhatsApp? We've updated it. People have helped it to build, to become what it is today. Are you okay? All right. So we talk about the users of the system. Okay. We talk about the developers of the system. Are we okay? The brainware. Brainware is people who are designing, putting it together. Okay. All right. So don't joke with it. You implement the GIS fine, and in the company, you see GIS is working. Someone in there, because they cannot have cut corners, will make sure that the data will not come. Are you okay? So you said data is one component, right? I will stop that. Are you all right? Then carry on with your GIS and let's see. This is a human being. Are you with me? But you said you had a system, isn't it? Right? Just like someone coming into an organization and saying, oh, I did some GIS in AIT, okay? I want to be in charge of GIS. He's not qualified. What you are learning doesn't make you an expert. Is that okay? Please, you won't make you an expert. There's a lot that we are learning there, okay? So that's what I'm saying, that people are the problem. It's not a professional. Yeah, it's a funny story of a lady and a husband. They run in a pharmacy shop. The lady is a pharmacist. Okay, the local people think that the husband is rather the pharmacist because he's a man. And so when they come in and the lady is there, they say, we want to see the doctor. You don't know about people. I won't talk much about it. You know what people can do. Are you okay? Okay, so Uber drivers are doing something interesting. You just make a request and then they'll tell you, where are you? Are you okay? When I make a request and then they call you and say, please, where are you and where are you going? In fact, they will be asking, where are you going? And they'll be asking you also where you are to. I'm like, what's happening in that? What's going on here? So what it tells you that literally they can destroy that system if they want. Are you okay? And they can make sure that Uber that runs in Europe won't be the same Uber that runs. Are you getting the people components? There's not much to say about it than just that. Is that okay? All right, great. What again? Methods. So the methods are very important, which means that you can know everything, all the principles in GIS, you can know them. You can be the great expert. But if you don't understand the business rule for a particular organization, you can implement GIS there. That's what methods stand for. What it literally means is that you need to understand how water is distributed. First, then you can say, I want to use GIS to solve a problem there. What are the principles by which water is distributed? This one is just, when I want to ask a question like this in the exam, I'll describe to you how water is distributed first. Is that okay? I will assume all of you know, but how is water distributed? Through networks of pipes. Okay, so do you know what I'm picturing? His answer is telling me that I just get a gallon of water and I'll just set up some network and I'll pour it